In the meantime, does anybody have any questions? Feel free to post them in the chat if you need to. How's everybody's first week with pandas? Love it, hate it. I was never much of a fan of it myself. Hello, Oksana. Kira. All right. Guess we'll go ahead and get started. Um, yeah, data engineering and pandas. Pandas is so much fun. So much fun. That's sarcasm. I hated pandas. I It is a very powerful tool. You will use it a lot if you're going to be doing data engineering. So one of the things we're going to be working with today is the pandas architecture so that you can understand what a series and a data frame is to make your pandas work a little bit better with you. We're going to do a couple data creations. We're going to build some data frames from dictionaries, from lists, from some CSV files. Let's see. Let's see. All right, good. And then from there, we're going to do what's called an ETL pattern. It's extract, transform, and load data using Pythonic best practices. We're going to do a data inspection. I'm going to show you how to use the head, the info, and the describe methods so that you can better understand your data. And then, like always, I'm going to kind of point out things for like code quality for ways that you can write clean, efficient, professional data engineering code. So as always, if you have any questions, feel free to come off mute or put it into the chat. I can see the chat here. And we'll go ahead and get started. So the key terms to know that you guys will be covering this week. A series is a one-dimensional labeled array. So the way I first looked at it is I spent a lot of time in VBA using Access and Excel. So to me, it's like a spreadsheet. So the series, you can think of it as a column in a spreadsheet or a Python list with labels. Then we have your data frame, which is the two-dimensional labeled table. So this would be more like a SQL table in Python, where you're going to have your your labels and your rows, right? The row labels. Let's see a hand. Oh, that's my hand. Why does this do that? All right, so I'm gonna put that hand down here. Thank you so much. So the row labels, you can generally label whatever you want, but the conventional method would be to use numbers like row 0, 1, 2, or custom labels like dates, IDs, names. That way when you extract, transform, or load, the process of getting the raw data, cleaning it, and preparing it for analysis, you can target the roles. So say you have IDs and then admin in your other row on the other side. So if you wanted the intersection of those, you would look for, the ID and the admin and see where they intersect on the spreadsheet, and that would be where you're going to get that data from. So data type of a column, it's going to be standard ones. You're going to have your 64 integer, your float. You have object, you can have a Boolean, you can also have a date and time. So these are critical to remember for your memory and your performance. And this is where you're going to first start getting into what's called vectorization. Like I know I touched on this a little bit last week with how your LLMs and your AI work. And one of the things they do is called a vector search. So when you create a data frame and your computer is organizing all of this data that you give it, it's going to give it 2 points, and that's what your vector is. And so for the computer to find the data that you're looking for more efficiently, especially with say like an LLM, the way they would match it is to look for the closest approximation of that vector and bring back the results. That's part of what makes them so fast on the semantic pattern matching and everything. They're not looking for whatever you're writing in the sentence. They're looking for the vector of the closest possible match of what they are predicting that you write, if that makes sense to anybody. If not, it's all right. It'll come later. So for today's topic, I'm going to touch quickly on Panda setup and imports. See if anybody's had any trouble with that. Let me just double check my attendance here. I see we got another one. Ben, welcome, Ben. Ben Chapman, got you. Sergey, son. Oh, there, good. All right, so introduction to pandas. As I was saying, pandas is a powerful open source library. It's going to provide data structures and make working with your structured data fast, easy, and expressive. So one of the examples here is without pandas, you would have to manually loop to process the data. With pandas, it'll do the vectorized operations like I was just talking about. Complex code versus one-line data loading, difficult data cleaning versus built-in cleaning methods. So like I was saying in week 1 and week 2, one of the most powerful things about Python is its libraries. So there is a library for just about everything you need. And so when you're doing data analysis and manipulation, one of the best ones that you can learn is pandas. So we do have the one-dimensional series and you have the two-dimensional data frame that we just covered. So here's where we're going to go over the setup, right? So this is your imports, and this might look a little strange. I don't know if I covered this last week with the aliases, but rather than having to call pandas as a whole word every time when you're doing something, you can assign an alias as the standard convention is PD, right? So instead of having to do like pandas dot version, pandas dot this, pandas dot that, you can shorten it. Same with NumPy, and the standardized one is NP. So it's still pandas. One second. And with the pandas and the NumPy, those are going to be two of your main tools. And then the path library, of course, is how you import the file path operations. So we should be able to run this. There we go. As you can see, pandas has imported successfully because of the pd.version. Thanks to the alias right here, you can see the pandas version is 2.2.2. And then the data directory .make directory, this is where we've created content week 4 data. Any questions on that so far? Okay. All right, so let's get into series. With a series, it's going to be a one-dimensional labeled data. So typically, this is an array capable of holding any data type. You can think of it, like I said, as a column in a spreadsheet or a Python list with labels instead of just positions. So in your vocabulary for your series, you're going to come across an index. An index is usually the row labels. These could be numbers, strings, dates, whatever it is to help you organize it. You're going to have the data, which is the actual values, and you're going to have the name, which is the optional name for the series. On top of which, you can do series versus Python list. So I'll show you a bad practice here. So using Python list for data operations is definitely a bad practice. Why? Because it's slow. Like if you have a large data set and you're trying to iterate through that list, you're going to be there for a very long time in computer time. It might just be seconds for a person, but for a computer, that's an eternity. So manual indexing is also error prone. And the last problem is there's no built-in data analysis methods. So if we were using a plain Python list, like say ages list, and we have the list of ages here, 25, 30, 35, 40, 45. To double all the values, you would have to do a loop or a comprehension for the double list. So in this case, we have the comprehension, which we covered last week. And so, yeah, it'll work. You can see that it doubled each one of them. But the problem is it's a manual operation, has no labels. And if this was thousands or millions of data entry points, going through that list like that and doubling everything in the list would just take forever. So for something small like this, you're not going to notice, but it's just bad practice. So I'm going to show you a couple of different solutions. We'll go through them slowly so that it doesn't kind of overwhelm you with any new material because I know this is going to be a lot this week. Like you guys are like, oh, I just started learning Python. Now all of a sudden you're throwing this pandas thing in here, and this guy's up here on a Jupyter notebook, and then NumPy, and this and that, and it seems like every week there's going to be something new thrown in your face. So I do promise at the end of this, it will all come together. So the novice solution for using pandas without having to worry about all the features would be simply to just do a series, right? So we have the same ages series, but this time we attach Panda to it, and we're going to use the series method on it. So inside of the method, we have our list of the 25, 30, 35, 40, 45. All right. And then down here, you can see that it's going to list them in the series with their little indexes, right? So then it also shows that the type, because we did type age series just to see what's going on in here. And from there, you have a series created from a list. That's great. That gives you something to work with. So take it a step a little further. Say we want to actually do something that would be real world applicable, right? So we're going to do a series with a custom index. So we're going to do the same thing we did before, but this time we're going to add meaningful labels to the default numeric index. So in here we have ages labeled, and again we're doing the pandas series. And inside the series, we're going to do the data, which is the values, but this time we're going to give it an index. The index is going to have these names for the custom labels, and then the name of the series. So when we print this, we're going to have a lot more things to work with. See, we're going to see intermediate solution, right? So we know that Alice is 25, Bob is 30, Charlie is 35. And then down here in the organization, we know its name, age, the data type is a 64-bit integer. Everybody follow so far? So you can see as you add a little bit more features to it, you're going to get more and more clarity of what you're doing with the data. And it might not seem like a lot right now, but imagine if this was maybe a roster for an entire curriculum or an HR department's payroll for an entire division of people that were hired, and you need to see who's coming up for retirement benefits or something. You wouldn't want to go through those hundreds of thousands of employees all by their date of birth. I mean, you could, but I think you'd be there for a little while if you're going to do a for loop and iterate if this greater than equal to 65, throw it in a set, and then return the result, and then list them. And then you still got to go back and be like, well, who is this person? Instead, you can just take the data that you already have, especially since it's usually going to be kept in either a JSON or a CSV file, and just manipulate the data with pandas and pull up what it is you're looking for. So the best practice, this is when we start bringing in the vectorized operations. So we're going to create a well-documented series. It's going to be just like the intermediate one. So, we have our ages. Again, we had to do the pandas series. We're going to have the data. We're going to have the index. We're going to have the name and the data type. And then when we call it, it's going to print ages. So let me show you what that looks like here. So now, in our vectorized operation, if we were to double all ages, so you see right here, we did just simply list ages times 2, or add 5 years, list ages plus 5. We could do statistics. I'm not going to confuse you guys too much with these right now, but there's the min, the mean, and the max. I don't know how many of you guys have done like variable calculus or anything, but min, mean, and max are going to be terms that you're going to learn a lot if you start getting into statistical data. And then there's also the sum. You can also do filtering. So like I was talking about with the retirement age, say you have ages greater than 30, and then down here, we make it readable for the human being because the computer doesn't care. It's just going to pull all that stuff up. But because of the way we did our pandas and our NumPy libraries, we now have this in a highly readable way to read it. And this is just the basics. I mean, you can add pretty little graphs, charts, matplotlib, you can get pie charts, you can get line graphs, you can have columns, you can make it look like a spreadsheet, whatever it is that your little data analyst heart desires. This library will let you transform your data into something that is not just code. Questions, concerns, comments? Nothing. All right. Okay. So, kind of data frames. So now we're going to add a second dimension to the data structure, right? So the series was one dimensional. A data frame is what you're going to work with the most. Like if you do work with pandas, you're going to see the majority of the time you're going to be working with data frames. And so yeah, so the good thing about data frames is you can do things that are called like chain indexing, you can modify copies, but you have to be careful because like you have to use the things like in place equals true very carefully because it'll modify the original data frame and return none. So if you're implicitly in place returning true and you wipe your entire data frame and that's your only backup copy, people are not going to be happy with you. So just be very careful when you use some of these commands because when you start working with data manipulation, you always want to make sure you have a backup and a backup of the backup. Like when I was doing databases, I always made sure that I had an iteration of the one that I was working on that day when I started the day, and then an iteration of the one when I started messing around with something I probably shouldn't be. Because 9 times out of 10, I was going to have to go back to the beginning of the day set. And if it really got bad, then I was going to have to go back to the day before and then recover everything. So when it comes to data, redundancy is your best friend. Just like I was telling you the last couple of weeks, documentation is your best friend. These are two terms that you're going to get sick to death of if you don't learn them quickly. Because without your documentation and without your redundancy, you're going to spend so much time doing recovery that it's going to frustrate you just beyond belief. And you're gonna have gray hair like me. That was a joke, it's not. I know it's not great, but I know my jokes are growing on you guys. I see you laughing at Kara. It's all right. All right. So let's create a data frame so you guys can see the difference, right? So we're gonna again start with the bad practice. So using nested lists and dictionaries without pandas, definitely bad practice. Why? Well, it's hard to access specific columns. There's no pre-built methods for analysis, and it's going to be difficult to add or remove data. You're going to be doing a lot of appends and things like that, and kind of losing track of what you're doing, right? So as you can see, it does work, right? We have our nested data with Alice, 25, lives in New York City. We can follow that. It looks familiar to some of our older lessons. You know, Bob, 30, Louisiana. Charlie, 35, Chicago. So it works. And then to get all the ages, you could loop through it with this bad practice that I conveniently named ages bad practice. So row one, for row in data nested. And you can see that it's going to bring in your ages. But accessing the data by row one is unclear and error prone. If you come back to this code that you wrote 6, 7 months ago, you might look at this and just be like, I don't really understand what I was thinking when I did that. I don't know why would I need to do row one? Um, so let's do a better solution. So this time we're going to use pandas. So data frame from a list of lists. So we have our data list. Again, Alice, 25, New York, yada, yada, yada. But this time we're going to drop it into what's called a data frame. So we'll name our first variable data frame novice. So we have our pandas, which we shorted with the alias for the PD. You see the method to the madness here. So instead of having to write out pandas 100 times, we can just do PD dot data frame, and we're going to call the data list. And it's going to load this list into our data frame so that we can manipulate it. Now that we have it assigned to data frame novice, we can start using that data frame like so. We could even manipulate and add stuff to it. So as you can see, data frames with a dot method, we added columns. So we're going to add the columns, name, age, city, after the creation. You know, this is already up here existing. But now we realize, well, some labels would make this more readable. Now you see name, age, and city. You know? And then we have our index numbers right here, 0, 1, 2. So that's the novice solution, which is good. It will get you through what you need to do, but it's not quite Pythonic. So we're going to take a step up and we're going to go to the intermediate solution. So what if we were going to do a data frame from a dictionary? That's a little bit better of a step up, right? So we have our data dictionary with our value pairs, right? We have our name, Alice, Bob, Charlie. We have our ages. We have our cities. Okay. So again, we're going to drop the data frame intermediate variable and put a pandas data frame in it using the data dictionary. Now it's loaded into this variable for us to manipulate. So again, we can access the column easily. So in this one, we're going to do a new line and we're going to print just the ages column, right? So then we can see right here in your ages column, 25, 30, 35. Nice and taken out of your entire data frame so that you don't have to go looking for it. All right, so best practice. And I know up front this looks like a lot, but it's really just systematically going step by step in an incremental way of what you've already learned. So in this next step, what we're going to do is we're going to use all the data frame features for data analysis. So we're going to create a more complex data set first, right? We're going to take the variable named employees, and inside it, we're going to drop a pandas data frame. And in that data frame, we're going to have names, we have ages, we have departments, and it's important to note that every one of these is separated by a comma here at the end, right? Except for the last one, so that it knows that you're done, right? So we have our salaries, which that would be nice. I will tell you, engineering actually probably makes a little bit more than that if anybody's looking into engineering. Start date. So here we're going to convert another pandas, right? So inside here, we're going to do to date time. So here are our date times nested inside of this data frame. So we're going to be able to complete the data frame. We're going to print the employees. Now you can see we can access it in multiple ways. We can access it by employee's age. We can do a dot notation, or we can do it in the bracket. Either way. We can do Boolean indexing. So we can look for anybody with a salary over $70,000. Yes, please. And then we can also just pop up quick statistics. So I'll show you what this looks like. Yeah, so again, still very readable, even though we've added quite a bit of stuff in this lump of code here that looks a little overwhelming at first. When the human being goes to review it, it's really not too bad, right? We have our names, we have our ages, we have our department, we have our salary, we have our start date. Then we have our number of employees, 0, 1, 2, 3, 4. So this is a very easy way for a human being to put it into a spreadsheet type format. And then you can see the column access methods, whether you do it with bracket notation or dot notation, it's going to give you the same result. We'll get into it later why you would use one over the other one, but for right now, all you got to know is if you're stuck, one of these will let you access the age of the employees in your data frame. The how and why of when to choose these, I wouldn't worry about just yet. When it comes time, we'll cover that. And then we have our filtering, so salary, everything over 70,000. So anything that evaluated out to true, which was Alice, Charlie, and Eve, is listed right here. Then we did some math and just got some nice little results right here because we did right here our little F string and evaluated it out into the print statement for us. So this is the length of the employees. This is the average salary. So we're going to do the mean and we're going to do it to 2 decimal places. So you see right there, there's your 2 decimal places. There's the length of the list, 5 employees. Questions? I know we're going through this a little fast. I just want to make sure we hit all the topics today so that we can handle more questions on Friday if you guys have them. Okay. All right. So loading data from files. This can be a little tricky your first couple of times. I've had a lot of coworkers and a lot of fellows in my classes that got stuck on this. So we're going to take a little bit of more time on this one. Loading data from files is going to be very important because whether you're doing it from an API call, a database, a JSON, or a CSV, 9 times out of 10, it's not going to be on your local machine, or it's going to be sent to you from Git or some other version control where you're going to have this large data file. And the first thing you're going to want to do is make sure that you load that data file correctly, that you can access the data. So we will go through the 4 most common ones, right? Let's start with the bad practice. no arrow handling. You're going to just assume the file's there, which every person in data analytics will tell you never trust the data. Don't trust that it's all right. Don't trust that there's no holes in it. Don't trust that the data is even correct. The first thing you always do with your data is you verify it and then you clean it and then you work with it. So this would crash if the file doesn't exist because we just did data frame, pandas, read CSV with the file's name. But if the file wasn't there, we don't have a try and accept or anything. So it's just going to crash. We're not going to know why because most of the time it is just going to give you a silent error. So problems, no file existence check, no error handling, no data validation. Those are way too many no's. It's a very, very, very bad practice. All right, so here's how we do a basic check, right? We're going to create simple data from practice and do a simple file existence check. So here we're going to have import OS. And I remember we covered that, I think in week 2, week 1. So import LS is going to give you a lot of these file loading commands that we were talking about earlier. So now that we have this import, we're going to be able to create a sample CSV file to work with. So the sample CSV is going to be right here. All this data in the CSV format. So we're going to write it with open. We're going to create this sample employees.csv, W as F, F.write sample CSV. So basically what this is saying is you're going to take all of this data that I have right here, and you're going to create me a local copy, and it's going to be in a CSV file format. And you're going to put this label on it so that I can find it. And W is for write. Right? Now, the next part is we're going to print. We're going to check if the file exists before loading. So if operating system dot path dot exists, the file we just created, then data frame equals the pandas read CSV, which is the one that we created. Then we have our print statement that says it loaded successfully. We have the print statement that shows us what it is. And then we have the data frame itself. Otherwise, we have our error, which is file not found. So that if this fails and we look down here, we're not looking at a blank terminal. Because the problem with computers is they like to fail silently most of the time unless you tell them to give you an error. Like all the error messages that you deal with in a terminal, those are generally flags that are put in there from debuggers or anything else. So I know you notice when you're installing something, like when you first installed Git, when you first pip installed something, if it worked, you didn't know because it just gave you the next terminal command and the cursor's just sitting there blinking. It didn't tell you, yay, thank you, take a hike, any of those things. You just nothing. So this is why we manually put in try and accept blocks because otherwise you don't know if it failed, you don't know if it worked. As we see here in this, though, we see that we have created this file. The shape of it is 5 deep, 4 across. All right, so let's make it a little cleaner, right? So we're going to do an intermediate with a try and accept with the CSV parameters, right? So this is a try and accept block. You're going to use these a lot. The try and accept is a very good way for graceful error handling, regardless of what it is you're doing. So this specifies useful read CSV PM parameters. So in here, we're going to start our try block. It's going to try this first, right? So we have the data frame. assigned to the pandas read CSV with all of this. Data type, salary, integer, so that it knows to look for those. So in here, we're going to load the file with the custom parameters. We're going to see if the length of the data frame fits, columns, the length of the data frame columns. We're also going to list the data frame columns, and we're going to list the data frame data types. If none of that works, we expect to find a file not found error. So in that file not found error, we're going to print, obviously, big surprise, file not found. If it's a pandas errors empty data error, we want to know that too, right? So instead of just saying file not found, let's be a little clear with this except, right? And say the file is empty. We found the file, but there's nothing in it. Or we could do a pandas errors parser error. So this is important too. What if it didn't download correctly? What if you don't have the right extensions? What if you don't have the right version number of whatever it is you're trying to open this file with? So the file isn't actually empty and the file is found. It's just not parsing correctly. And you can do more of these too and narrow it down. Like say that there's specific things that you're looking for. This is just 3 examples that I loaded in here to give you guys an idea of how you can, get more verbose with your error messages so that you know what's going on with it. Instead of just being like, oh, it doesn't work. Well, why doesn't it work? Oh, well, it didn't find the file. Or, well, no, it found the file. It's not parsing the file correctly. You can see how those will save you a lot of time in trying to diagnose more than just a ambiguous, I don't know, it didn't work. Now we will show you the best practices. So I don't expect anybody to know how to do this or even remember how to do this anytime in the near future. But this is production ready data loading function. If you can learn this and you plan on doing data analytics or any type of source control, your teammates will love you very much. Because this is a reusable function, it's going to have comprehensive error handling. It's going to return none on failure, which is easy to check, and it's going to include the validation. So in order to do that, we're going to add another import, right? We're going to do path library import path. So the definition of this function is going to be load CSV safely. So now that we've defined our function, we're going to give it its parameters because every function needs parameters. Well, I mean, it'll work without it, but you want to define your function with parameters. It will make your life a lot easier. So in here, we know we're going to give it a file path, and we're going to give it a keyword argument. And then this is a .type string. I don't know if I've covered this with you guys before. It's just a professional way to load what your function does. So it's literally the definition in a docstring format for readability of what this function does for a human being to come along and just glance quickly and be like, oh, okay, you defined load CSV safely. What does it do? Oh, well, it loads a CSV file with comprehensive error handling. It takes 2 arguments, the file path, the keyword argument. And then it returns the data frame if it's successful and none if failed. So instead of having to sit here and go through all of this and decipher whatever this coder did, if he was conscientious enough for his future self or his teammate and put a doc string in here, you can just simply look right here and know what this function does. Or if the function isn't working, what it was intended to do. So you can see how that can make your life a lot easier when you're debugging millions of lines of these. So now we have the file path equals path file path. So we've loaded that into the variable, right? Now we're going to check if the file exists. So if not file path dot exists, we're going to print our first error message. It's going to print file not found, and it's going to give the file path that it was looking at so that you can go in there and look and be like, oh, it had a 1, not an L, or something like that, because you know the file's in there. And you're like, I know it's in there. Why aren't you seeing it? Well, you can check where it's looking and see what it's seeing. Otherwise, it's going to return none and keep on going. Then it's going to check the file extension. So if file path, and we're going to do suffix dot lower, is not, you'll see with the exclamation right there. Exclamation always means the opposite. So is not is how that reads out. A CSV file. And we're going to throw another flag. Warning, file might not be a CSV. And then we're going to show what we're looking at. Is it a PDF? Is it an ODT? Like, what is it we're working with? Instead of having to go and look for it, return it right here in this F string so that I can see what it is you're snagging up on. So after we get those two checks, next we're going to try the data frame. We have pandas, and we're going to do our read CSV. We have our arguments, the file path and the keyword argument. So the first thing we're going to do, we're going to validate the loaded data. And you hear this from me a lot over these next 7 weeks. Anytime you hear us talking about data, I'm always going to tell you, validate the data. Or can it be empty? You don't want to spend all your time trying to validate an empty list if it was meant to be empty and it's waiting to be filled. So if the data frame is empty, we're going to print our next flag, warning. Data frame is empty. Print, it loaded. So you say, we did load it so that you know that the file exists, the extension worked, and we got to this step. So we loaded it, but this is how long the data frame rows are. This is how long the columns are. And this is where we got it from, just to make sure that you're actually pulling the correct one up. And then it's going to return that data frame. If that doesn't work, then we're going to have our except cases down here where it catches it. This is just like we did up here, where we have empty data error, the parser error, and then everything else. So E is just kind of a way to print whatever's going on in here, right? So exception as E. This is the exception. So when it will do the unaccepted error, we have the alias of E. So instead of having to write exception, 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 you just put a little lowercase e in there and keep on trucking. Because then this F string is going to return whatever this exception is. Same with the parser error as E. So whatever this big parser error is going to get brought up in this little variable in the F string so that you can just copy that and throw it into your helper and just be like, what is this? Why is it doing this? How do I fix it? So you see how that is a little bit more verbose and a little bit more Pythonic on how to deal with these situations. It's fundamentally the same thing we did in the last two steps. It's just a little bit more flexible. Does that make sense to everyone? Okay. So now that we have our safe loading function, because it's going to run through all of that. And if it passes all of that, then we know the data frame is safe. So we're going to load the CSV safely. We have our sample employees. And as long as if data frame is not none, and I know that seems like a double negative. So if data frame is not none, you're going to print the data preview. And in the data preview, this is the first of the commands I was showing you. Data frame head. So head is going to do the first 5 rows. Because say your data frame is 300,000 rows and you tell it to print data frame, you're going to be sitting there for a while because your terminal is going to print all 300,000 rows before you can put any other command in. So if you don't need to see all those or manipulate all those right now, you can just put the head and say, just show me the top 5 rows so that I know what we're working with. I don't want to be here until my lunch break waiting for you to list off everybody on the Eastern Seaboard. So then we can test with a non-existent file so that it won't crash, right? So testing with the missing file, it will give you the result equals load CSV safely, non-CSV. We'll print the result, and then let's see what it looks like when it runs. So yeah, as you can see, this is what happens when you give it the head, right? So even if there was 100 of these, because we gave it the command head, it's just going to do 1, 2, 3, 4, 5 of them. Then here's what an error message would look like. Very readable. Big red X, catch your eyes. Questions? I know that we just jumped through a lot of stuff very quickly. Okay. All right. So I'm just going to touch briefly on section 5 since we're getting close to time. And then if we do have any questions at the end, do feel free to drop them in the chat or come off with you. So for section 5, it's data inspection. So after loading data, what do I always say? Always inspect it first. This helps you understand what columns exist, what data types are present, are there missing values? Also, what if it's got fillers? A lot of people will be lazy and they'll drop like a nan in all the empty blocks, or some CSV extensions instead of an empty block will put nan or put a 1 or a 0. And if you're doing statistical analysis, those ones and zeros will mess up your averages. Just like the nan will crash it because it's not a number. If you fill in something and you're looking for the averages and you drop a bunch of zeros in there, it's going to drop your average and give you a bad result. So that's what you want to know. You want to know, is there missing values? Can it be empty? Can it be empty because the user was lazy? Can it be empty because the data was not available? Or can it be empty because you're grabbing it from multiple sources and not everybody has the same columns? Say somebody has name, age, type, but another one has name, age, location, and another one has name, demographic, and I don't know, sex. That's still a type, but it's not the same thing. So the computer's not going to listen to the same thing. So instead, what it's going to do is it's going to create a row for all of those. And then a third of your data is going to be missing stuff from 2/3 of the rows, and so on and so forth. So you see how you're going to have these empty gaps that you're going to have to accommodate for that you wouldn't know if you didn't inspect the data. So if you inspect the data, then you'd be like, why is it doing that? And it might be something as simple as going in and standardizing all the name columns or all the indexes so that they are all the same. And then you reduce the 9 to a 3 because they'll all be standardized. Make sense? All right. So these are some of the essential inspections. Thank you, Sana. And like I said, you don't have to memorize these. Like I've showed you guys where DevDocs is and MDN. So just knowing that they exist and knowing where to look for them is very important. Like you can go on DevDocs. Let's see, I think I have it right here. And in your DevDocs, make sure you guys can see this. Okay, good. So in your DevDocs, they actually have a pandas section. And so in your pandas, you have all your documentation, right? And you drop in here. Here's your data frame, your offsets, your general functions. So you don't have to, give yourself an aneurysm trying to memorize all of these things. And like Zoom does with my and it's all in here. Same with other libraries, Pygame, which is what we did the tank game with over Thanksgiving, right? Your different Python versions, pandas, NumPy. We didn't really cover NumPy today, but this is a big mathematical thing that is going to let you crunch a lot of numbers. Later, I'm sure we'll probably get to another one that's called Matplot Library, and we'll work with that one as well. So all of these are in here. Let's see, let me make sure Matplot, it should be. Well, that one you might have a better idea. It's kind of specialized, but you get the idea. Most of it's in there. So the biggest thing is just knowing your documentation and knowing where to look for everything. So the essential methods that you'll use a lot is the head and the tail. So you can specify, like the default is 5, but say you want to see like the top 25. Then in the head, you would put 25 in place of end. Same with the tail. The shape is that tuple that we saw earlier that gives you the rows and the columns. Dot info will give you the column types, the memory. This is very, very helpful. So the non-null counts, because that's another thing you don't want. You don't want nan and you don't want null if you're dealing with numbers, especially if you're doing statistics or averages or anything like that. You want it either to not be there or be the correct number. Describe will give you statistics for numeric columns. Then data types will give you data type of each column. And then, of course, the dot columns will give you a list of the column names. So, like I was saying earlier, bad practice. Printing the entire data frame. In the real world, data frames are millions and millions and millions of lines of data usually. Like here in practice in this class, we might keep it to like 1,000 rows, but even 1,000 rows in your terminal would be a lot. So, for example, with large data, this would crash your notebook or it would flood your output. And your eyes are just going to gloss over it. There's not going to be any understanding of the data structure. So create larger sample data. So in here, we're going to make a large data frame. So this pandas data frame is going to have an ID with a range of 1,000. We're going to give it a value for everything 1.5, 4x in a range of 1,000. We're going to give it some categories. We're going to give it 3 spots so it'll go AAA. And then let's run it. Let's see if it crashes this notebook. No, because we put in here, don't do it. If we were to call that, let's take a look. Let's see here. Feeling brave today since we're almost out of time. Why don't we print a large data? Let's see. All right, so we got lucky because it's using the default heads, right? But you can see how this could get really, really bad because you have your first 5 and you have your last 5. But if I didn't have the head and the tail on there as the default part of the pandas library, all of that in between would have printed out. And you would have this long streaming 1,000 rows with 3 columns filling up this notebook right here, possibly crashing the notebook. So here's basic inspection methods. You want to do like I just did with you with the head and the tail. And like I said, you can specify. So say you want the bottom 25, the top 25. And boom, there you go. We go through 25 and then the last 25, right? It's still the same 1,000 rows and the same 3 columns. The data is all there, but we're just dealing with the top and the bottom of it. So intermediate, you can combine the methods. So again, we have a complex data frame right here. You have your head, you have your info, and you have your describe. So I'm going to show you what those look like real quick. So in here, we have the head, we have the column, we have the non-null count, and we have the data type, the describe. So we know we have an object, we have a float, and down here goes with the data types. We have one float, two integers, and two objects. We also know that our memory usage is 332 bytes. Not a lot. Statistics. Here's the count, the mean, the max, the 25, the 50, the 75, all the basic ones you would use, right? And for the Grand Slam, we're going to do the shape, the memory, the columns, put it all into one nice data profile. So here we go. This is how you make friends in the data analytics industry. Here's your data profile for products inventory. The shape is 5 rows by 5 columns. It's only taking up 80 kilobytes of memory. The columns have, this is really important when you start bringing in SQL or Postgres. You have your product ID, you have your name, your price, your quantity, and your category. These are the data types you're working with. You have integers, you have objects, you have floats. You are missing one price. So 20% of your values are missing in this. Numeric column summary, and then categorical column summary. So you can see how you can just get more and more flexible and more detailed about what you're working with. All right. And with that, we will stop and hold for questions if anyone has any. Feel free to drop them in the chat if you don't want to come off mute. All right. Well, that brings us at time for today. So you guys are free to go back to your Wednesdays. Have a good evening. You have any trouble, as always, you can DM me on Slack or reach out to my co-instructor, Ritam, and I'll see you guys again on Friday. Welcome, Ben.
Thank you.
You're welcome, Asana. Sergey, see you later. It is. It is a lot to digest. So feel free to just take your time. I did drop some documentation in the link in the Slack so that you guys can go over a little bit. And like I said, you don't have to learn everything all at once. Like Pandas is a whole thing all by itself. So don't let it overwhelm you.